In the domain of science and enormous secrets, the topic of what existed before that enormous detonation has sparked mixed discussions and intrigued personalities for a long time. This significant inquiry doesn't just challenge our understanding of the universe, it challenges the very limits of human knowledge. Imagine standing at the edge of existence, gazing into the vast darkness, and pondering what lay there before our universe was conceived. The event of the Big Bang marked the beginning of time-space and everything we know. However, was there a moment before this? Could there have been a state of nothingness, a quiet, before the cosmic ensemble began? And if so, what might that have been? Or perhaps something even more unnerving existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the universe's origin into concepts that defy comprehension. Physicist Brian Cox, known for his investigations into the wonders of the universe, proposes that something startling could have existed before the Big Bang. He challenges us to reconsider our notions of reality and existence. In this exploration, we'll examine the science, theories, and mind-bending mysteries that may explain what existed prior to everything. We'll explore ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we've uncovered may not only stun you, but could also unlock new understandings of our place in the universe. Prepare to dive into a world beyond imagination and science, where the unknown still weaves shadows, leaving researchers flabbergasted and sometimes even disturbed. The Big Bang and what might have preceded it. To comprehend what may have existed before the Big Bang, we first need to carefully examine what the Big Bang truly was. Scientists define the Big Bang as the moment when the universe became extraordinarily hot and dense, expanding rapidly, and setting off the formation of all matter, energy, and forces. When we gaze at the night sky, we see evidence of this event, with galaxies spreading out from a primordial point. But why did this occur? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from void or tranquil. Cosmic inflation, a before Big Bang universe. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and relaxed, almost like a vast vacuum. However, this vacuum wasn't entirely empty. It contained a tremendous amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, occurred so quickly that it laid the foundation for everything that followed. In a fraction of a second, space expanded at unimaginable speeds. Eventually, this expansion slowed, and the energy transformed into matter particles and forces leading to the Big Bang. But what was the nature of this energy? Why did it swell the universe, and why did it stop? Researchers believe that cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly, with tiny bubbles forming here and there, each bubble representing a universe including our own. This idea, known as the inflationary multiverse, suggests that there are potentially infinite Big Bangs and an endless number of universes. Our universe is just one of many. This immense, mind-bending reality challenges our comprehension of the cosmos and leaves us asking, what else is out there? The concept of nothingness before the Big Bang. The idea of nothingness before the Big Bang is theoretical, not absolute, at least according to our current understanding. Even if all energy, particles, and radiation were removed from the universe, it would not be truly void. The universe is filled with dark matter, dark energy, quantum fields, and other forces that form an unavoidable tapestry of something, even in its most empty form. Imagine stripping away all these forces, leaving only a dark void. Even then, the universe would generate new forms of energy. This alone is puzzling to researchers, as it suggests that true nothingness may be impossible within our cosmic framework. Space itself has inherent properties, rules, and constants that prevent it from being completely empty. For instance, there is the phenomenon of zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can briefly appear and vanish, creating a ghostly echo of movement even in seemingly empty space. This challenges the concept of a true void and suggests that even before the Big Bang, there was something we are only beginning to understand. Eternal inflation, the perpetual creation of universes. One of the most astonishing hypotheses in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it is conceivable that it could continue indefinitely. Physicist Brian Cox describes an inflationary multiverse where universes are endlessly created and continue expanding. Imagine each Big Bang as a spark, lighting another universe while inflation continues in other regions, creating countless other universes. This process could, in theory, go on forever. This idea gives birth to a captivating concept, a fractal universe, where each new universe potentially creates its own Big Bang. Each universe exists as a separate, independent realm, unaffected by others due to the rapid expansion of space. For scientists, this theory is both exciting and unsettling. It suggests a perpetual multiverse with no definitive beginning or end. What if our universe is just one speck in a giant cosmic structure, endlessly expanding and creating forever? Quantum fields and the origins of reality. Quantum field theory also offers profound insights. According to this theory, the universe is not just a collection of matter floating in space. It is an intricate network of energy fields that interact to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even in their lowest energy state, the vacuum state, quantum fields remain active. Particles can appear and vanish briefly, acquiring energy before returning it. These so-called virtual particles challenge the idea of a true void. Imagine an empty universe stripped of all matter, radiation, and energy. Would it be total nothingness? Quantum field theory suggests it would not. Even in a vacuum, fields remain active, sometimes producing transient particles. This constant movement prevents absolute nothingness. The role of dark energy. Dark energy, the mysterious force driving the accelerated expansion of our universe, may also hold clues. Some scientists propose that dark energy today is a remnant of an energy field from before the Big Bang. Dark energy's properties suggest a tremendous hidden force that may have shaped the conditions leading to the birth of our universe. In a much stronger state, it might have powered the inflationary phase, causing rapid expansion. This raises profound questions. Could dark energy have been the silent architect of cosmic inflation? Could it even be the true origin of our universe? Cyclic cosmology, an eternal rhythm of universes. An alternative to the Big Bang as the ultimate beginning is the idea of cyclic cosmology, the theory that the universe goes through infinite cycles of birth, death, and rebirth. In this model, the Big Bang is not a singular event, but part of an eternal rhythm where universes expand, collapse, and are reborn. This theory suggests that our universe might have emerged from the remnants of a previous universe. The contraction and expansion in this cyclic pattern imply there was never a true beginning, just an infinite series of universes evolving and rejuvenating themselves over and over again. Cyclic cosmology challenges our understanding of time. It suggests that time may be cyclical, not linear. If this theory is correct, what existed before the Big Bang was simply another iteration of the universe, one that collapsed, only to give birth to our current universe. For scientists, this theory provides a rich explanation of ultimate origins, proposing that the universe has always existed in some form, transcending human concepts of time and existence. Primordial gravitational waves. Clues from the earliest moments. Another intriguing idea lies in primordial gravitational waves, ripples in space-time caused by massive astronomical events. These waves could carry information about the universe's earliest moments, offering insights into what happened in the first fraction of a second after the Big Bang. Some theories even suggest that gravitational waves could originate from a pre-Big Bang era. If such waves existed, detecting them would provide direct evidence of events or conditions from before inflation and the hot Big Bang. However, finding these waves is a tremendous challenge. Scientists are developing advanced instruments to detect these subtle ripples, hoping one day to unveil a hidden layer of cosmic history. Such discoveries could answer questions not only about the universe's earliest stages, but also about the deeper cosmic forces that ignited its existence. Quantum foam and vacuum genesis. Physicist John Wheeler introduced the concept of quantum foam, which suggests that spacetime at the smallest scales is not smooth, but filled with constant fluctuations of energy. These fluctuations give rise to brief appearances of particles and energy, creating a bubbling, frothy structure. The vacuum genesis hypothesis builds on this idea, proposing that the universe may have arisen from a massive quantum fluctuation within this quantum foam. In this view, the Big Bang was not the beginning of everything, but the result of one of these fluctuations growing until it became the universe. This theory redefines the concept of nothingness. Even in the absence of matter, energy, and conventional spacetime, a dynamic reality persists. If our universe is the result of a quantum fluctuation, it suggests that countless other universes may be emerging and disappearing within this quantum ocean. Quantum tunneling. A universe from another realm. In quantum mechanics, quantum tunneling allows particles to pass through energy barriers even when they seemingly lack the energy to do so. Applying this concept to cosmology, some scientists propose that our universe might have tunneled into existence from another realm or plane of reality. This process could involve energy breaking through otherwise insurmountable boundaries, leading to a universe emerging from another dimension. If true, it suggests that the Big Bang was not the ultimate beginning, but the result of a boundary being crossed, a moment when our universe spilled into existence. Quantum tunneling adds a mysterious layer to the question of what existed before the Big Bang, hinting that our universe might be just one of many in a much larger cosmic structure. The Big Bounce, a cycle of collapse and expansion. Another hypothesis is the Big Bounce theory, which posits that the universe alternates between cycles of expansion and contraction. Rather than the Big Bang being the absolute start, it might have been a rebound from a previous universe's collapse. This theory aligns with the concept of a cyclic universe, suggesting that time, space, and matter are part of an eternal process of creation, destruction, and recreation. If true, our universe's beginning was simply the aftermath of a previous universe's collapse, continuing an endless cosmic rhythm. The limits of understanding. As we explore these hypotheses, it becomes clear that our understanding of the universe's origins is limited but steadily growing. The Big Bang was once thought to be the singular moment of creation, but modern theories like inflation, the multiverse, and quantum fields suggest a far more complex picture. Physicists like Brian Cox encourage us to imagine that something existed before our universe, something powerful enough to ignite the Big Bang and set the chain of events into motion. These ideas are both exhilarating and humbling, reminding us of the vast mysteries yet to be uncovered. For now, we stand at the edge of what we know, gazing into the unknown with curiosity and awe. The universe, with its intricate design and hidden secrets, inspires us to keep asking questions and seeking answers. Whether through theoretical advancements, new observations, or revolutionary discoveries, humanity's quest to understand what existed before the Big Bang continues.